Once, they were some of the most advanced structures on the planet. At the cutting edge of engineering design and construction. Today, they are derelict, contaminated, and sometimes deadly. Their empty buildings and infrastructures are full of the echoes of real people and vanished lives, leaving many questions unanswered and mysteries unsolved. In this episode, we tap into the history of electricity to find out if a giant structure rusting away in the contaminated zone around Chernobyl could have started World War III.
500 feet tall, 1,500 feet long. So what? It has the computer processing power of any computer in the 1970s. It's minuscule. And if they get it wrong, it's the start of World War III.
We explore the remains of Nikola Tesla's revolutionary power generator on Long Island to ask if his plans to provide limitless power for the world would have worked.
I think what he was trying to do with this was develop power transmission and wireless power, because those Tesla coils are actually creating and sending radio waves.
The ornate control room at the heart of Hungary's oldest power station reveals the belief that electricity would create a new and better world.
You've got to see this as a projection of the future to everybody. You're trying to show your nation and people around that you're forward-thinking, you're entering a new era.
And we ask why a brilliant mathematician has been forgotten, even though the structural design he invented has been used to create some of the world's greatest buildings.
It's a work of art, it's a work of engineering, it's a work of maths.
The strange force known as electricity baffled mankind for centuries. Then, in the late 1800s, scientists discovered a way not only to generate electricity, but also to harness it. As a result, life on Earth was transformed forever. In the east of Ukraine, close to the Russian border, is the site of one of the most extraordinary electrical structures ever built. Looming over the landscape is a giant latticework of steel beams and cables, which, except for the creaking of its steel plates in the wind, today stands silent. Once, this incredible machine could be heard around the world. This is the Duga Woodpecker.
You look at the Woodpecker and you think, wow, this is post-apocalyptic. This is a movie set. I could see James Bond. I could see, Bruce Willis. It's that kind of eerie silence today that makes you think this could make a great film for an abandoned civilization on Mars. It's just that weird.
At over 1,500 feet long and nearly 1,000 feet high, the Duga over-the-horizon radar system was created during the dark days of the Cold War. But what part did it play in those decades of global tension?
The general idea of the over-the-horizon radar comes from the late 1940s. And before this period, the Americans built what was called the Distant Early Warning Line. And it was a string of literally dozens of radar installations in Canada's far north. These were essentially line-of-sight radars. And even if you put them on a mountaintop, you're not going to get too much more than 100-something kilometer range under best conditions for those kinds of radars. Now, the over-the-horizon radar will give you an ability to scan an area literally thousands of kilometers range.
The Duga was a state-of-the-art installation designed to make use of the ionosphere, the upper layer of the Earth's atmosphere.
The thing you have to remember is obviously the Earth is curved, okay? So that sort of limits the distance that any wave that the radar might be giving out can travel, basically to the horizon. So if you want to see things that are further away, you need to be able to make the wave sort of bend or go around with the curvature of the Earth. And one of the ways you can do that is, thankfully, we have this ionosphere, which with these sort of low frequencies that we're talking about with radar, they can't go through, so they literally just bounce. So you can actually utilize that to try and get your waves to travel further and then back again.
Now, certainly it's because of the availability of computers to calculate the necessary frequency changes that you need to do to bounce those signals off the ionosphere and down. And of course, to get the return off the ionosphere radars to work, you need a massive sender and you need a massive receiver. Even the most sophisticated modern radar, over-the-horizon radar apparatus, you can't miniaturize these things. They are vast installations.
With its ability to detect incoming missiles, the Duga would be in the front line of any future war. But would it work?
It's not really clear how well this thing would work, and I guess we know that more now that we understand the ionosphere and these sorts of things a bit better, because you're inherently going to smear out the pictures and everything, because you know the ionosphere it's not a perfectly smooth layer. It's got variations going on in there. So all these sort of complications means that it's not as easy as it is with sort of usual radar to kind of really triangulate where the signal's coming from, exactly how far away it was, because there's many ways it could have bounced.
The Soviets knew that a nuclear missile would take only minutes to arrive. So speedy, accurate reading of incoming signals would be vital. A false reading would spell disaster.
You've always got to put in the human element with these sorts of things. Unfortunately, even the best scientists, you know, we're wired by the human brain to identify patterns that may not even be there. So yeah, you could be seeing things, willing things into existence because you're on edge. You know, think of the historical times, Cold War, all that sort of stuff. People are on edge. You know, they really want to be able to have this early warning detection system. There may have been a huge number of red flags.
The Woodpecker is testament to the fact that big does not mean better. It's 500 feet tall, 1,500 feet long. So what? It has the computer processing power of any computer in the 1970s. It's minuscule. So what this means is that the results have to be interpreted by an individual who is, well, it's a human for a start, and if they get it wrong, if they think that maybe this is an incoming missile and not a bird, which has caused this fluctuation, then guess what? It's the start of World War III.
Like all such installations, the construction and operation of the Duga was shrouded in secrecy. But it was a mistake by the Soviet authorities over frequencies that gave the game away and earned Duga its nickname.
The Russian radar appeared almost as people called it the Woodpecker, but it had a dot, 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 dot when you heard those radar signals. Radar signals themselves tended to jam and interrupt all kinds of standard civilian frequencies, including airliner radio frequencies. They later had to change some frequencies there because there were so many international complaints.
The tapping from the Woodpecker continued until 1986, The Duga's location had been carefully chosen to allow it to draw on the massive amounts of electricity generated by the nearby Chernobyl nuclear power plant.
The Woodpecker was constructed in the 1970s, but it was still up and running in the 1980s, leading some to speculate that the power that it was drawing in and the signals it was producing may have caused the Chernobyl power plant to explode. Whether this is true or not remains a matter of speculation.
When reactor number 4 at the plant exploded on April the 26th, a huge area was contaminated by radiation. The entire Duga complex and the accommodation for its 1,000 workers were abandoned overnight. However, some people felt that the Duga was not a victim, but the cause of the disaster.
The Woodpecker sums up brilliantly the Cold War generally, really. Advancements in technology and engineering that couldn't go fast enough at the time, built big on a huge scale, intimidating. But yet when it came down to it, it was never ever really used. And now it sits quietly, wasting away in the middle of an exclusion zone from Chernobyl. And maybe that's the image that we're left with when we look up at the Woodpecker. Thank God this was never used.
Now, the once mighty Woodpecker lies abandoned in the Ukrainian forests. A decaying reminder of fears of all-out nuclear war. Too expensive to demolish and impossible to reuse. The Duga Woodpecker is not the only remarkable electrical remnant of the Cold War. Hidden in woods at Istra, just outside Moscow, is a smaller but just as eerie structure. Looking like a relic from a science fiction movie, the Marx machine is in fact an electrical generator. But the energy generated by the Marx machine dwarfed its rivals. For a fraction of a second, it was able to create an artificial lightning bolt with more power than the combined output of all Russia's power stations. But what was its purpose? During the 1970s, the nuclear arsenals of both East and West were too evenly matched for either side to risk a first strike. So the Soviet Union began looking for other ways to disable US ballistic missiles.
There was a wide variety of defenses and systems in place on both sides, and we had a pretty good idea of their missile capabilities, and I think they had a pretty good idea of the capabilities of our weaponry.
One side effect of exploding nuclear weapons is that they generate a massive surge of power called an electromagnetic pulse, or EMP, which can knock out all kinds of electronics, including the guidance systems of missiles. Lightning also generates an EMP. Soviet scientists began to believe that if they could create a machine to harness the destructive power of lightning, they'd be able to paralyze the USA's missile arsenal.
We had cruise missiles, which were possibly our most effective weapon for targeting Soviet airspace because they flew nap of the Earth, and they are extremely difficult to pick up on any kind of radar, and certainly the radars and early warning systems that they had in the 1970s.
The technology behind the Marx machine began with a late 19th century invention called an electrical generator, or coil.
Those coils are actually great at creating and sending radio waves or any sort of electromagnetic waves. With that, they inherently have power associated with them. So you've turned electrical power into an electromagnetic power that you can then transmit.
More work on generating electromagnetic energy was carried out in the 1920s by the German scientist Edwin Marx and the Russian Vladimir Arkachev. Working in complete secrecy, Soviet scientists developed their theories to create a machine they christened the Arkachev-Marx High Voltage Research Center.
To be able to harness essentially just these wiggles of electricity and magnetism into something useful that has transformed the world.
Значит, существует инструкция по облету грозовых облаков не менее чем за 30 километров. Тем не менее, в атмосфере остаются такие электрически сильные поля, что самолет сам провоцирует разряд молнии, и в среднем за год 1-2 удара самолет получает.
The machine was capable of unleashing an astonishing 500 feet long artificial lightning bolt, but only for 100 microseconds. Controlling the artificial lightning would be the next step. But the machine used up vast amounts of energy and was also very expensive. By now, it had also become obvious that the USA was carrying out its own EMP testing, and the USSR no longer had the technological edge if it came to war. Then in 1989, the Soviet Union collapsed, and the money for the Marx machine simply ran out. What could have been the world's ultimate weapon has been left standing quiet and alone in its forest lair ever since. Another revolutionary electric magnetic generator stood at Warden Cliff on Long Island in the United States. Hidden among the trees in this beautiful area east of New York is all that is left of a grand plan to revolutionize life on Earth. A plan that would have made Warden Cliff a power center for the whole planet. Could this implausible idea ever have worked? And who was the secretive and obsessed inventor behind it?
Today, we take electricity for granted. But at the turn of the 19th century, it was the new black. It was full of wonder. It was a cure-all for almost anything, and its potential was limitless.
This is a time of, power and electricity and all this sort of science, which is the way it should have been done, is seen almost in a sort of magical aspect, right? And they used to put on big shows to promote this. There are huge amounts of propaganda in the same way that you may see that a magician or something would do like that. They were treated in that sort of way.
All that is left at Warden Cliff today is a ruined and vandalized laboratory building. From all over the world, people come to explore these damp corridors and to look for clues about what happened here. During the early years of the 20th century, rumors were rife about mysterious experiments, strange flashing lights, and the reclusive figure, half-genius, half-mad scientist who was working here. His name was Nikola Tesla. Neil Badgett is a member of the Tesla Science Center at Warden Cliff. He is convinced that Tesla's ideas were capable of changing the world.
Tesla was a unique man. He was very private. He worked all the time. He was obsessed with inventing. I think he wanted to help the world. He wanted to do things that would benefit all of humanity.
The scale of Tesla's vision was obvious from what he planned at Warden Cliff. It would have required a kind of engineering that had never been seen before.
We're standing on the base of the Tesla Tower, a 187-foot high tower erected with wooden beams. And the thing on top, a big round copper hemisphere, was really a capacitor to hold voltage. He charged it to as much as he could, millions of volts, so high that he would go beyond the capacity and it would send out bolts of lightning.
This unique capacitor was Tesla's best-known invention and was used in dozens of experiments. It would unleash a stream of electricity straight down into the Earth to a special underground chamber. From there, it would travel along radiating tunnels and out into the Earth's crust.
I think what he was trying to do with this was develop power transmission and wireless power, because those Tesla coils are actually creating and sending radio waves or any sort of electromagnetic waves.
And he believed that he could set up a standing wave of electric potential within the crust of the Earth. A standing wave that's like a wave on a string attached to a jump rope. You move it just right, you got a standing wave, it doesn't travel. And all around the Earth would be these peaks and valleys of voltage. If you could tap into them, you could pick up power or maybe information. If you modulated the wave, you send information.
I think that sort of vision of creating power and distributing it out through a network, that's something that we have taken on board. Now, maybe not directly from Tesla, but it's another case of that's what needed to happen to transform the world, and we've done it.
But powerful forces were mobilizing against Tesla's plans at Warden Cliff. His decision to opt for alternating current instead of direct current for his huge machine brought him into conflict with the other great name in electricity, Thomas Edison.
Edison had direct current, DC, and Tesla had his alternating current and AC. And there was a bitter rivalry between them, a real war between these two people. And Edison was just a better marketer than Tesla. Tesla was very focused on the science, on the possibilities, and even thinking way ahead into the future. Like, this is how we change the world, which we have eventually done. The thing with the alternating current is that it was so much more useful for transmitting power. The DC current, it's like, well, that's essentially what we use. We only use that in batteries now. That's all we use DC current for. Power stations, it's so much easier to generate power in AC in huge quantities. It's so much easier to transmit that power over power lines. And even Tesla was starting to talk about what we are now trying to develop, which is wireless power.
Tesla was perhaps his own worst enemy when it came to the rivalry with Edison. His secretive experiments and obsessive behavior made it easy to portray him as an oddity.
Edison was able to smear him. He put on shows to show the dangers of alternating current, electrocuting elephants to shock people into thinking, no, DC's the way to go, it's safer, and all that sort of stuff. And so, Tesla sunk into depression, he got ill, and he died a very poor man, unfortunately, because, as we know from after his death, it was him that was right. He had the right track with alternating current. He even, perhaps they think, came up with radio before Marconi ever really did any of that. So Tesla, whilst being right, unfortunately, was not appreciated in his time.
When Tesla's main backer, the leading financier JP Morgan, pulled out of the Warden Cliff project, he had no choice but to cancel the whole project. Even the giant tower had to be demolished for scrap, leaving nothing but a giant circle of foundation stones.
The really disappointing thing about the Warden Cliff Tower project is that it was halted halfway through due to, allegedly, lack of funding. Really? JP Morgan's your backer and he doesn't have money? Or is it possibly because Tesla is creating free energy that nobody can make any money off of? I think we need to look at that quite carefully.
Today, some dedicated supporters of Tesla's ideas are still working in obscure research labs around the world in pursuit of his Warden Cliff dream. But the potential of limitless energy also had a sinister side. Tesla himself put forward the idea of using energy to create a superweapon. And in the 1980s, the US Air Force carried out a series of tests to create artificial lightning, which they called Project Tesla. In its remote forest hideout, the Soviet Marx machine was on the same path. The world has yet to see if Tesla's visions of the future of electrical power, both good and bad, will become reality. By the early 20th century, conventional power stations were springing up around the world. In the district of Kellenfold in Hungary's capital city, Budapest, is one of the oldest and most beautiful power plants in the world. This is Kellenfold Power Station. When it began operating in June 1914, Kellenfold rivaled anything in the world for efficiency and high output. Today, the production of power is a basic industrial process, and plants are constructed with just efficiency and cost in mind. What Kellenfold's designers wanted to produce was a temple to electricity.
The generation of power itself is so simple, all right? It really is. You take something incredibly simple, you know, a turbine that spins around a magnet inside a coil, that's essentially all it is. But then you have to put all these sort of regulations and extra things in there to make it usable. And that's being the transformers, the systems to make sure the turbines are going around at constant speed the whole time so you don't get interruptions. All this sort of stuff had to be worked out, and you're talking about, you know, very old technology. The way we do it now is very different from what was available back then. You know, they had to think of a lot of things and be ingenious with creating these things to make the AC useful.
To produce electricity, Kellenfold needed steam to drive its giant turbines. The vast furnace hall is where mountains of coal and hundreds of thousands of gallons of water from the nearby Danube were brought together to begin the process.
It is coal and water creating steam and turning magnets inside coils. Fundamentally, it's exactly the same from a science and physics point of view. So that tells you we haven't come up with a better way of generating energy. Even nuclear, instead of using coal, we still put them, you know, heat water turbines. It's exactly the same. And yeah, so our electronics have got better, our transformers are better, we lose less power in sending them via pylons and everything like that. But if you're going right back to the heart of the actual generation of that electricity, the best thing I can say is it's still done the same way.
Kellenfold was built at a time when the Art Deco style of design was transforming utilitarian structures. Art Deco's impact is immediately obvious in Kellenfold's unique control room. Its curved walls and dramatic glass ceiling show how much effort went into turning the new power plant into a showpiece. Tibor Horvath is manager of the power plant that replaced the original Kellenfold.
Kellenfold was always famous about how can it improve and how can you use the latest technology. The control room was very important for the regulation of the power plant and the management of the equipment, electrical equipment. And this kind of technology, transformers, switching gears, it was first in Europe, this design, but was very famous during the next 20 years.
got to see this as a projection of the future to everybody, and therefore, there can be elements of design going into that. You're trying to get people on board. You're trying to show your nation and people around that you're forward thinking. You're entering a new era, and so yeah, why not incorporate some design elements into that?
The new power plant soon became a showpiece in Hungary, and its layout and design style was copied all over Europe.
I think it's great that they tried to kind of pour design Art Deco, make it stunning, and it still looks amazing. It looks fantastic. I don't know how practical it was in there, the sound issues and all manner of things like that. But I don't see why, you can't have design and function go hand in hand. Why not?
Although World War I broke out just 2 months after Kellenfold went online, the brand new plant escaped damage. But 20 years later, it became a prime target for Allied bombing raids. Its design was now given a new element. Dozens of 1- and 2-man concrete bomb shelters were built all over the plant, even in the ornate control room.
Bunker was built during the Second World War. That fortunately, this control room and the bunker didn't need any protection because, fortunately, the previous staff had only one bomb, but on the yard. The buildings and the roofs was not affected by bombs.
I really wonder about air raid shelters in the middle of a factory or a factory industrial installation. Certainly, deep underground is the only one that makes sense. But the idea of putting individual shelter right in the middle of the target seems to me rather strange, and it goes completely against all of the studies done in the 1920s and 30s by German engineers who were looking at possible future war and designing factories with the idea of minimizing damage and easing the repair and the firefighting systems if you were hit by an airstrike.
After the war, Kellenfold remained at the heart of Hungary's energy supply, until, after 91 years in operation, it was decommissioned in 2005. Today, even after years of decay and neglect, its glories are still admired around the world. Standing abandoned by the Oka River in far-off eastern Russia is a revolutionary electricity pylon. This amazing tower is the result of a building technique devised 120 years ago, which today can be seen in some of the world's greatest structures. It's a unique combination of art and architecture. This is the Shukov Tower.
The Shukov Tower is very striking. You look at it and you're not entirely sure why, but you know there's something different about it.
It's almost mind-bending looking at that thing, And you've got to think, well, it looks like there's all this curving steel and all stuff like that, and you've got to remember, no, every piece in there is straight.
It's a work of art. It's a work of engineering. It's a work of maths.
Tatiana Vinogradova has spent a lifetime studying the work of its designer, a man who pushed the boundaries of mathematics and engineering. His name was Vladimir Grigorovich Shukov.
Вы знаете, самое интересное в том, вот я вообще сама думаю о Шухове очень много, да? Может быть, это наивно, но у каждого из нас два полушария. одно ответственно за образность, а другое за аналитику, за математику. У кого-то лучше работает одно полушарие, у кого-то лучше работает второе. Так вот, у Шухова блестяще работали два полушария. Эта башня работала. Она строилась не просто как памятник, гиперболоидная башня, а она несла свою функцию. Это опора, линия электропередачи. Вот здесь, на том месте, где мы с вами стоим, здесь шла линия на ту сторону. Вы знаете, для того, чтобы провода шли на ту сторону, да, нужно было поставить целый каскад башен. Была не одна башня, а 8.
I think the Shukov design is very pioneering because a lot of these masts were there to be practical and we just needed to get the height and we wanted to do it with as little steel as possible and just get up there. But I think Shukov thought a little bit deeper about the problem. He thought about how we could actually make it look beautiful, how it could be mathematically very precise. And he came up with what I think is a very, very beautiful and unusual structure.
The Shukov Tower was one of 8 built in 1927 to carry power lines across the Oka River to vital Soviet industries in the city of Nizhny Novgorod. It was one of 2 420 feet high towers standing on the north bank. But could Shukov's revolutionary design cope with the weight of the cables and the effect of winds blasting across open country?
He must have had to do so many calculations to work out whether this thing was feasible. And he kept it in that simple, elegant, beautiful design. Almost transparent nature, right? All those beams are very, very thin. That you can imagine winds being able to pass through it without causing that much of an issue. So in a way, it's very efficient, if complicated design, perhaps.
Any engineer designing a tower that's going to be hundreds of meters up in the air needs to consider the effect of wind. That wind is going to be striking it, even if you can't feel anything on the ground. Up there, there's going to be forces acting against your tower, effectively trying to bring the thing down. If you look at an example like the Eiffel Tower, you can take a look at that and say, it's quite a squat structure. It's got a wide base, and it kind of tapers in towards the top. That looks pretty solid. Shukov's towers don't have that. They're much more graceful, yet somehow, using his mathematical mind and putting that into practice, he's created towers that have that grace and elegance, but still do the job.
Shukov even devised a remarkable new way of constructing his towers.
I think the way they built the Shukov Tower is actually quite clever. You could have put the different segments next to the base and then lifted it in on top. What they did was to work in the same direction. So all they had to do was lift it up upwards rather than upwards and sideways. So I think it actually probably made the whole operation a bit simpler.
Shukov became world leader in 1896 when he devised a water tower with a lightweight but extremely strong grid structure known as a hyperboloid design. This involved using straight beams mounted on a circular base. Every beam was slanted sideways and inwards at a precisely calculated angle to create a gradually narrowing tower.
It's got a curved profile, it has a curved shape to it, yet all the members and the constituents of it are long and straight.
How do you work out how strong this structure is going to be, how resilient it's going to be to wind and all these sorts of things? It's almost boggling how he was able to come up with it. So different from anything else that's come since.
Расчетов этих конструкций до него не было. То есть он сам придумывал методы расчета, он сам давал расчеты, и вместе с тем работала его блестящая интуиция. Он чувствовал, как конструкция себя будет вести.
Though Shukov had also used his system to create lightweight building frames, it was his tower design which immediately caught on. Over the next 20 years, he built nearly 200 of them. Next, Shukov planned to construct a monumental 1,100 feet radio tower in Moscow. But Russia was in the grip of a revolution, so not enough steel was available, and it had to be limited to just over 500 feet. Completed in 1922 and named the Shabalovka Tower, it was the first major construction project of the new Soviet Union and established Shukov's reputation as a brilliant structural engineer. But would his giant tower have worked?
Not only would Shukov's tower have dwarfed the Eiffel Tower, it would have been 3 American football fields tall. Imagine that.
I believe Shukov could have done it. I think he could have got up to 300 meters because his structure was so incredibly elegant, so incredibly light, and so perfectly oriented with all the different steel beams coming in to create stability that I believe he would have done it.
Shukov built no more towers, but his genius inspired other engineers to copy his revolutionary design. The Hearst Tower in New York and King's Cross Station in London are just 2 famous buildings which were inspired by his use of the diagrid hyperboloid. Shukov's name may be unknown to most people today, but his legacy will live on. In the late 19th century, electricity was still a mysterious and almost magical power source. Yet in less than a century, it became indispensable to a huge proportion of the world's population. The relics of the early years of electrical invention and the way it became essential in both war and peace serve as reminders of how far we have come. After being abandoned for decades, Tesla's Warden Cliff site has been rescued from oblivion. There are plans to preserve what is left of his revolutionary power system and encourage more study and understanding of his life and work.
There's so much about his life that was such a pity that we don't have those sort of monuments there with the hindsight we do have now about how brilliant he was. It's a real shame that they just stripped it for parts, essentially.
The Duga woodpecker's remote location in the Chernobyl radioactive exclusion zone has helped preserve it for the last 30 years. The gigantic steel radar system has now become a lasting monument to the paranoia of the Cold War.
Today, the woodpecker looks as though it was frozen in time. It's a dead zone. It's post-apocalyptic. This used to be something that was so strategic and so important. It has this kind of threatening aura about it. Here's something that could have caused World War III. It's still imposing.
Just like Tesla and Shukov, today's engineers and scientists are pushing the boundaries of what can be achieved with electricity and how it can be delivered. Inevitably, these new discoveries will one day turn what is now state-of-the-art technology into more awe-inspiring abandoned structures.